Now let us start with the different types of reaction intermediates that will be formed during the reaction. So the very first reactive intermediate that will be formed is the free radical. So let us go into detail of the free radical. So we have already discussed that a free radical is formed when there is homolytic cleavage of a bond. So free radical is formed by the homolytic cleavage of a bond. So they are very reactive. Now if it is very reactive, this means they will be staying in the reaction mixture for a very short time, so they are short-lived. Now why they are very reactive? Because they have an odd unpaired electron and it will try to combine with something so that it can be stable. So it will try to pair up as soon as it can. Okay, now for example, if we have chlorine molecule and it is exposed to UV light, it will undergo homolytic cleavage and it will lead to the formation of 2 chlorine free radicals. Now, because this is unstable, now if in the reaction mixture we have methane, so we can write it like this. We have methane. Now what will this chlorine free radical do? It will be leading to the homolytic cleavage of one CH bond and leading to the formation of methyl free radical. Sorry, this is HCl. Methyl free radical and HCl will be formed, right? Now again, this methyl free radical, it is going to be very reactive and it will react further. That detail we will be going into when we will be discussing the different types of organic reactions, right? So this is how a free radical is formed. Now what are the types of free radicals? So let me just clear my screen. So now we are moving into the types of free radicals. So there is methyl free radical, then there is primary free radical, then there is secondary free radical, then there is tertiary free radical. Methyl, primary, secondary and tertiary free radicals. Now methyl free radical is CH3 free radical. Now, what is a primary free radical? Now, for understanding what is a primary free radical, we need to know what is a primary carbon. If a carbon is further attached to one more carbon, suppose we have CH3, that is the ethane molecule. Now, if we see this carbon, it is attached to one more carbon. So this carbon will be considered as the primary carbon. Similarly, this carbon will also be considered as the primary carbon. Okay, now if a carbon is attached to 2 more carbons, then it is a secondary carbon, and if it is attached to 3 more carbons, then it is a tertiary carbon. Now we will be looking into the free radicals. So the primary, this is the methyl free radical, then the primary free radical will be CH3, CH2 free radical. Now the carbon which is containing the free radical, it is attached to only one carbon atom. Then the secondary free radical will be the carbon containing the free radical. It will be attached to 2 carbon atoms. Okay. Then the tertiary free radical is the one in which the carbon containing free radical is attached to 3 carbon atoms. Right now we need to understand the order of stability of the various free radicals. So when we were discussing hyperconjugation, we said that the stability of free radicals can be explained on the basis of hyperconjugation. Now let us draw the hyperconjugating structures for these free radicals. Okay, if we consider methyl free radical, it has no alpha hydrogen, because it does not have the alpha carbon. The carbon next to the free radical carbon will be the alpha carbon. So it is not having any alpha carbons. There is no alpha hydrogen. So no hyperconjugation. Take lots of notes. Okay. Do not just look into the videos. Keep writing it. Then we are moving to primary free radical. Now the carbon next to the free radical carbon will be the alpha carbon. Now it is having 3 alpha hydrogens. So we will be able to write 3 hyperconjugating structures. So let us draw the hyperconjugating structures for primary free radical. So here it is. Now we can consider this bond. Now 1 electron of this bond will move towards hydrogen. The other will move towards this free radical and it will come here, and there will be the formation of this species in which the free radical is now on hydrogen. Okay, then we can consider these 2 hydrogens also. So here is the free radical. Then the third hydrogen. Cool. So here 3 hyperconjugative structures are possible, right? Now let us move to the secondary free radical. So in case of secondary free radical, there will be 2 CH3 groups attached to the carbon having the free radical. So there are 6 alpha hydrogens. So we can open up one of the 2 CH3 groups. So here is the free radical. Now consider this hydrogen. Electron moves here, this electron moves here, this electron moves to the hydrogen. So it is so likewise you can draw it for the other 2 hydrogens. Okay, so next we will be considering the second CH3 group here. Okay, so now I can write it like this. I'm just writing this as CH3. Now when we will be involving this CH3 into hyperconjugation, it will be looking like this. Now this carbon will have a double bond with this carbon, and one will be the one hydrogen will be carrying the free radical. Okay, so you just can write the other 2 structures also. So these are the 6 possible hyperconjugating structures when we are talking about a secondary free radical. Now your assignment is you need to draw the hyperconjugative structures for tertiary free radical. So the structure of tertiary free radical will be like this. Okay, now 9 alpha hydrogens are there. So 9 hyperconjugative structures will be possible. So you need to draw it, you need to take a picture of it, and you need to post it in the comments below. This is your assignment. Okay, do it and do it with your hand. Just looking into the video is not going to help you. Okay, so now next type of free radical we are moving into is benzyl free radical. Benzyl free radical. So benzyl free radical is this free radical. Now in this case, the stability of this free radical is explained on the basis of resonance. It is stable because of resonance. Why we are calling it resonance? Resonance is involved in conjugation. This means here hyperconjugation is not going to be there. Here it will be conjugation. Why so? Because its sigma bond is not involved. Here the pi bond is going to be involved. So if we see the distance between this double bond and this free radical, how much distance is there? One bond distance is there. This means this free radical and the pi bond is in conjugation. So we can draw it like this. Okay. So these two electrons are there. This will move here. This will move here. This will move to the carbon. So this is the free radical. Now we need to move in one direction only. So we will be considering the next double bond. So now this free radical and this double bond, they are in conjugation with each other. So it will be like this. This is half-headed arrow. This is not full-headed arrow. Okay. So here will be the double bond. Here is the double bond. Here we have the free radical. The next double bond. Next double bond, again, it is in conjugation with the free radical because of one bond distance. So here we can take the two electrons. This electron will move here. This will move here. And this will move here. Okay. Now again, we are coming back. This free radical and this double bond, they are in conjugation with each other. So here, one electron here and the other electron back to its position. So this electron will keep jumping from one atom to the next atom and energy will be getting consumed. So it will lead to the decrease in energy of this free radical. So lead to the stability of the free radical. Okay, so here will be the bond. So this is how we explain the stability of benzyl free radical. The next is the allyl free radical. Allyl free radical. So the allyl free radical is CH2 double bond CH2. So when here is the free radical, it is allyl free radical. Now this free radical and this double bond, they are in conjugation, very much clear. So CH2, here it is free radical. So again, it can go this way. And it will keep jumping from one carbon to the other carbon, right? So this is how we explain the stability of allyl free radical. So benzyl free radical and allyl free radical, they are stable because of conjugation, because of resonance, because pi electrons are involved in the stability. But the alkyl free radicals, that is the methyl, primary, secondary, and tertiary free radicals, they are stable. Their stability is explained on the basis of hyperconjugative structures possible. Now, what is the order of stability of tertiary, secondary, primary, and methyl free radical? You need to write it in the comments. So you have two assignments out of this video. One is you need to draw the hyperconjugative structures for the tertiary free radical. Second is you need to tell me what will be the order of stability of these four free radicals. Okay, so let us now move into the structure of free radical. Structure of free radical. So the carbon which is containing the free radical it is sp2 hybridized. Carbon containing the unpaired electron, that is a free radical, it is sp2 hybridized. So if we are taking methyl free radical, this carbon will be sp2 hybridized. So when the carbon is sp2 hybridized, what is the structure? It is trigonal planar. Trigonal planar. So here is the carbon, here is the trigonal planar structure where it is forming 3 sigma bonds with 3 hydrogen atoms. In case of methyl free radical, if it is some other, it can be here CH3 or like that. And the 1p orbital which is unhybridized, it is carrying the odd electron. So this is the unhybridized p orbital. Good enough? Okay. Next, we will be now in the next video, we are now moving into the carbocation intermediate. Okay. So see you in the next video.